Hello grade 9 learners! Today, we are going to talk about special parallelograms. Let us have the expectations for this lesson. Number 1. Identify quadrilaterals that are parallelogram. Number 2. Prove theorems on different kinds of parallelogram, namely rectangle, rhombus, and square. And lastly, state the different characteristics of a special parallelogram. Now, let us have the pretest. Directions. Read each of the following carefully. Choose the letter that corresponds to the correct answer. Number 1. In a rectangle CALM, measure of angle MLC is equal to 30 degrees. What is the measure of angle ALC? A. 30 degrees, B. 45 degrees, C. 60 degrees, and D. 65 degrees. You have 10 seconds to answer. Your timer starts now. Number 2. In a rectangle CALM, LD is equal to 15 cm. Find the length of diagonal CL. A. 15 cm, B. 20 cm, C. 25 cm, and D. 30 cm. Your timer starts now. Number 3. Quadrilateral LIVE is a square. If the measure of angle VLE is equal to 3x plus 9, find the value of x. A. 12, B. 13, C. 20, D. 25. Your timer starts now. Number 4. In rhombus FREN, what is the measure of angle FNR? A. 35 degrees, B. 55 degrees, C. 70 degrees, D. 110 degrees. Your timer starts now. And number 5. What is the measure of angle RFN? A. 35 degrees, B. 55 degrees, C. 70 degrees, and D. 110 degrees. Your timer starts now. Let's check your answers. These are the answers in pretest. You are doing great! Before we proceed to our lesson, let us have a recap. Direction. Refer to the figure below to solve for the required part. Quadrilateral CARE is a parallelogram. Number 1. If side CA is equal to 12 cm, what is the measure of side ER? Number 2. If diagonal CR is equal to 14 cm, how long is SR? Number 3. If the measure of angle ARE is equal to 75 degrees, what is the measure of angle CAR? Number 4. If the measure of angle ECA is equal to 100 degrees, what is the measure of angle ERA? And lastly, if ES is equal to 5.5 cm, how long is diagonal AE? Write your answer on your notebook. And here are the answers in recap. You are excellent. Now, let us proceed to the discussion of our lesson. In the previous lesson, solving for angles and sides involving parallelograms were discussed thoroughly using its properties. Now, we are going to discuss the other quadrilaterals that are known as special parallelograms. Let us recall the hierarchy of parallelograms. Look at the diagram. This is the hierarchy of parallelograms. Rectangle, rhombus, and square are quadrilaterals that are parallelograms. They are known as special parallelograms. They are special since all the properties of parallelogram are present in square, rhombus, and rectangle. Now, let us prove theorems on special parallelograms. Let us start with rectangle. So here are the characteristics of rectangle. Number 1, opposite sides are parallel and congruent. Second, opposite angles are congruent and supplementary. Number 3, all four angles are right angles. Number 4, consecutive angles are supplementary. Next, diagonals bisect each other and are congruent. And lastly, each diagonal separates the rectangle into two congruent triangles. So again, these are the characteristics of rectangle. Now let us proceed to theorems on rectangle. Theorem number 1. If a parallelogram has right angle, then it has four right angles and the parallelogram is a rectangle. Given quadrilateral MATH is a parallelogram with angle M is a right angle, prove that angle A, angle T, and angle H are right angles using the given figure. Let us now discuss the proof using two columns with statement and reason. Number 1. Quadrilateral MATH is a parallelogram with angle M is a right angle. Reason given. Next, angle M is equal to 90 degrees. Definition of right angle. Number 3, angle M is congruent to angle T, and angle A is congruent to angle H. For the reason, in a parallelogram, opposite angles are congruent. Number 4, measure of angle M is equal to the measure of angle T, and measure of angle A is equal to the measure of angle H, by definition of congruent angles. Next, measure of angle T is equal to 90 degrees by substitution. Number 6, measure of angle M plus measure of angle A is equal to 180 degrees, since consecutive angles are supplementary. Next, 90 degree plus measure of angle A is equal to 180 degrees by substitution. And number 8, 90 degrees is equal to 90 degrees by reflexive property. And then, measure of angle A is equivalent to 90 degree by substitution. And at the same time, measure of angle H is equal to 90 degrees, again by substitution. And number 11, angle A, angle T, and angle H are right angles. For the reason, if the measure of an angle is 90 degrees, then it is a right angle. And therefore, quadrilateral MATH is a rectangle, by definition of rectangle. Let us have examples. Use rectangle MATH and the given information to answer each. Number 1. If the measure of angle MAH is equal to 25 degrees, find the following. Letter A. Measure of angle HAT. Letter B. Measure of angle THA. And letter C. Measure of angle AHM. So let us now have the solution to solve for angle HAT. Since quadrilateral MATH is a rectangle, measure of angle MAT is equal to 90 degrees. So the measure of angle MAH plus the measure of angle HAT is equal to the measure of angle MAT by angle addition postulate. Now let us substitute the given values. 25 degrees plus the measure of angle HAT equivalent to 90 degrees. And then, subtract 25 from both sides. Therefore, the measure of angle HAT is equal to 65 degrees. Let us now solve for the measure of angle THA. So since quadrilateral MAT is also a parallelogram, angle MAH and angle THA are congruent. Therefore, the measure of angle THA is also equivalent to 25 degrees. Now, let us find the measure of angle AHM. Similarly, angle HAT and angle AHM are congruent. Thus, the measure of angle AHM is equal to 65 degrees. Now, let us have theorem number 2. The diagonals of a rectangle are congruent. Given quadrilateral MATH is a rectangle with diagonals MT and HA, let us prove that diagonal MT is congruent to diagonal HA. Let us now discuss the proof. Number 1. Quadrilateral MATH is a rectangle with diagonals MT and HA. The reason given. Next, side MH is congruent to side AT. Since in a parallelogram, opposite sides are congruent. Then, angle MHT and angle ATH are right angles. For the reason, if a parallelogram has right angle, then it has 4 right angles, and the parallelogram is a rectangle. Then, measure of angle MHT is congruent to the measure of angle ATH. All right angles are congruent. And so, HT is congruent to TH by reflexive property. Hence, triangle MHT is congruent to triangle ATH by side angle side congruence postulate. And therefore, diagonal MT is congruent to diagonal HA. For the reason of corresponding parts of congruent triangles are congruent. To further understand, let us have examples. Quadrilateral MATH is a rectangle. Find the value of x and the specified sides. Number 1. If diagonal MT is equal to 5x minus 14 and diagonal HA is equal to 4x plus 6, find the following. Letter A, the value of x. Letter B, diagonal MT. And letter C, side AS. Let us have the solution. To find the value of x, since the diagonals of a rectangle are congruent, diagonal MT is equal to diagonal HA. So let us just substitute the value of MT and the value of HA. So 5x minus 14 is equal to 4x plus 6. And then 5x minus 4x is equal to 6 plus 14 by addition property of equality. And therefore, the value of x is equal to 20. To solve for the value of diagonal MT, we will just substitute the computed value of x. Since x is equal to 20, then diagonal MT, which is equal to 5x minus 14, will be equal to 5 times 20 minus 14. And therefore, diagonal MT is equal to 86. And now, let us solve for side AS. So, since diagonal MT is equal to diagonal HA, then HA is equivalent to 86. Then, twice the value of AS is equal to HA. So, 2 times AS is equal to 86. So, to solve for AS, divide both sides of the equation with 2. Therefore, the value of AS is 43. So, we are through with rectangle. Now, let us proceed to rhombus. So, here are the characteristics of rhombus. Number 1, all 4 sides are congruent. Opposite sides are parallel. And also, opposite angles are congruent. Consecutive angles are supplementary. Diagonals bisect each other and are perpendicular. Each diagonal bisects a pair of opposite angles. And finally, each diagonal separates the rhombus into 2 congruent triangles. Now, let us have theorem number 3. The diagonals of a rhombus are perpendicular. Given quadrilateral FREN is a rhombus, let us prove that diagonal FE is perpendicular to diagonal RN. So let us now have the proof. For the first statement, of course, quadrilateral FREN is a rhombus for the reason that it is given. And then, side FR is congruent to side RE for the definition of rhombus. Next, diagonal FE and diagonal RN bisect each other for the reason that diagonals of a parallelogram bisect each other. And so, D is the midpoint of diagonal FE. Since diagonal FE bisects RN at D. Then, FD is congruent to DE for the definition of midpoint. Then, side RD is congruent to side RD, reflexive property. And now, triangle FDR is congruent to triangle EDR by SSS congruence postulate. And so, angle FDR is congruent to angle EDR, for corresponding parts of congruent triangles are congruent. Hence, angle FDR and angle EDR are right angles for the definition of linear pair. And therefore, we can say now that diagonal FE is perpendicular to diagonal RN because perpendicular lines meet to form right angles. To further understand the theorem, let us have examples. Quadrilateral FREN is a rhombus. Find the missing value using the given information. Number 1. If diagonal RN is equal to 20 cm, find side ND. Number 2. If the measure of angle NDE is equal to x squared plus 65 degrees, find the value of x. Let us have the solution for side ND. Since rhombus is a parallelogram, its diagonals bisect each other. Thus, if diagonal RN is equal to 20 cm, then side ND is equal to 1/2 of diagonal RN. And then, side ND is equal to 1/2 times 20. Therefore, the value of side ND is equal to 10 cm. Now let us find the value of x. The diagonals of a rhombus are perpendicular. Thus, angle NDE is a right angle. So here is the solution. Measure of angle NDE is equal to 90 degrees. Of course, by the definition of right angle. Let us now substitute the given values. So x squared plus 65 degrees is equal to 90 degrees. And then, the resulting equation now will be x squared equal to 25 degrees because we subtract 65 from each side. And then, get the square root of both sides. So therefore, the value of x is 5 or negative 5. So now let us proceed to theorem number 4, in which each diagonal of a rhombus bisects opposite angles. So given quadrilateral FREN is a rhombus, prove that angle 1 is congruent to angle 2. Also, angle 3 is congruent to angle 4, using the given figure. Let us now discuss the proof. So again, for the first statement, it is always the given. Then the next statement now is that side FN is congruent to side FR. Also, side RE is congruent to side EN for the definition of rhombus. And then we must say that NR is congruent to RN by reflexive property. And then, triangle NFR is congruent to triangle REN for SSS congruence postulate. Therefore, we can prove that angle 1 is congruent to angle 2 and angle 3 is congruent to angle 4, since corresponding parts of congruent triangle are congruent. Now, let us have examples. Quadrilateral FREN is a rhombus. Find the missing value using the given information. If the measure of angle 1 is equal to 33 degrees, find the measure of the other numbered angles. So use the given figure for your reference. Now let us have the solution. Since each diagonal of a rhombus bisect opposite angles, therefore, measure of angle 1 is equal to the measure of angle 2, as well as the measure of angle 3 and the measure of angle 4. Thus, if the measure of angle 1 is equal to 33 degrees, then measure of angle 2 and measure of angle 3 and measure of angle 4 is also equivalent to 33 degrees. Now, let us find the measure of the remaining numbered angles. So, since the diagonals of a rhombus are perpendicular, therefore, measure of angle 5 is equal to 90 degrees. So, since measure of angle 1 plus measure of angle 5 plus measure of angle 6 is equal to 180 degrees, then measure of angle 6 is equal to 180 degrees minus measure of angle 1 minus measure of angle 5 by substitution. Now, measure of angle 6 is equal to 180 degrees minus 30 degrees and minus 90 degrees. So therefore, the measure of angle 6 is equal to 57 degrees. Similarly, measure of angle 6 is equal to measure of angle 7, as well as the measure of angle 8 and the measure of angle 9. So therefore, measure of angle 7, measure of angle 8, measure of angle 9 are all equivalent to 57 degrees. And now, let us proceed to the characteristics of square. So the very first characteristic of a square is that all four sides are congruent. And also, all angles are right angles. And then, opposite sides are parallel and congruent. Opposite angles are congruent and supplementary. Also, consecutive angles are supplementary and congruent. And diagonals bisect each other and are perpendicular and congruent. At the same time, each diagonal separates the square into two congruent triangles. Let us have theorem number 5. The diagonals of a square are congruent and perpendicular. Given quadrilateral BEST is a square, let us prove that diagonal BS is congruent to diagonal ET. And also, diagonal BS is perpendicular to diagonal ET. Let us use the given figure. So this is now our proof. Of course, the first statement and reason are always given. If quadrilateral BEST is a square, then side BT is congruent to side ES. Since the properties of a square, opposite sides are parallel and congruent. And so, angle EBT is congruent to angle BES, since all angles of a square are right angles. And then, side BE is congruent to side EB by reflexive property. Now, we can say that triangle EBT is congruent to triangle BES by side-angle-side congruence postulate. And then, diagonal BS is congruent to diagonal ET because corresponding parts of congruent triangles are congruent. And now, side YE is congruent to side YT because diagonals of parallelogram bisect each other. And then, BE is congruent to BT because all sides are congruent for a square. And then, BY is congruent to BY by reflexive property. And now, triangle BYE is congruent to triangle BYT for side-side-side congruence postulate. And so, angle BYE is congruent to angle BYT for corresponding parts of congruent triangles are congruent. And then, angle BYE plus angle BYT is equal to 180 degrees for the definition of linear pair. So twice the measure of angle BYE is equal to 180 degree by addition property of equality. Hence, angle BYE is equal to 90 degrees. And therefore, BY is perpendicular to ET and diagonal BS is perpendicular to diagonal ET for definition of perpendicular. So to further understand the theorem, let us have example. Number 1. If side YE is equal to x plus 5 and diagonal BS is equal to x plus 25, find diagonal TE. Solution. Diagonal TE is equal to diagonal PS since diagonals of a square are congruent. Diagonal TE is twice side YE. So by substitution, TE is equal to x plus 25 and twice YE is equal to 2 times x plus 5. Then, x plus 25 is equal to 2x plus 10 by applying distributive property of equality. And then, by subtraction property of equality, the resulting equation now is 25 minus 10 equals 2x minus x. Therefore, x equals 15. So, after finding the value of x, we can now substitute it to solve for diagonal TE. So therefore, diagonal TE is equal to x plus 25 and substituting the computed value of x which is 15, so TE is equal to 15 plus 25. Therefore, diagonal TE is equal to 40. Let us have another example. If the measure of angle SYT is equal to 4x plus 10, find the value of x using the given figure. Solution. Since diagonal TE is perpendicular to diagonal BS, then angle SYT is a right angle. So we have measure of angle SYT equivalent to 90 degrees. And then let us now substitute. So 4x plus 10 is equal to 90. And then by subtracting 10 both sides, 4x will be equal to 80. And then divide each side of the equation by 4 to solve for x. And therefore, x is equal to 20. Now let us have the wrap-up. And let us remember that rectangle, rhombus, and squares are special parallelograms. Second, the square is the most special parallelogram because all the properties of parallelograms and the theorems on rectangles and rhombuses are true to all squares. And also, let us remember the theorems related to special parallelogram. For a rectangle, if a parallelogram has right angle, then it has 4 right angles and the parallelogram is a rectangle. And also, the diagonals of a rectangle are congruent. With regards to rhombus, the diagonals of a rhombus are perpendicular and each diagonal of a rhombus bisect opposite angles. And for the theorem on square, the diagonals of a square are congruent and perpendicular. And now for our valuing, let us have your reflection. The theorems related to special parallelograms reminds us with the distinct characteristics of rectangle, rhombuses, and squares. In consonance of being special, it tells us that we are all special and unique. As a unique person, share your perceptions on what makes you special.